Lesson 14.3, probability of compound events. Let's start this by giving an example. What's the probability that it will rain today? Well, it's actually fairly low probability, so we'll say it's 0.20, also known as 20%. And the forecasters looked at tomorrow and said, you know what, tomorrow is also even lower. It's 10%, or 0.10. So the next question is, all right, what's the probability it'll rain today and tomorrow? Well, to do that, we actually multiply them together. This is confusing why we multiply one time and don't multiply others, so you're going to have to practice a lot to get good at it. But you'll find then the chances that it rains today and tomorrow, if there's 20%, 10%, is only 2%. So this is a simple event. It's a compound event when I put them both together. Simple as just one day. Compound is both. And we say they're independent because, believe it or not, if it rains today, it has nothing to do with whether or not it rains tomorrow based on the original probability. The weather forecaster looked at it and said, I think there's 20% chance today, 10% tomorrow. If it rains today, he's not going to revise tomorrow based on that fact. He's just going to say, fine, it rained today. It was pretty unusual. You only had a 1 in 5 chance, but still tomorrow I still think there's only a 1 in 10 chance. Dependent events are different. Dependent events where the first one actually impacts the second one. And I'll show you a good example of that in a second because it gets very confusing very quickly. You have to do your probability differently, but you're still going to multiply them. So the classic, marbles in a bag, so lifelike. What's the probability we pull a red? Well, that's simple. It's 8 out of 40 because 8 plus 12 plus 9 plus 11. There's 40 marbles. That's 1 out of 5. What about a blue then? So that's the red. I think I'll just color coordinate these. Well, blue, there are still 12 blue, but notice that in the problem it says we did not replace them. So now there's only 39 marbles. And that's equal to 4 out of 13. And green. Well, we didn't replace again, but we haven't touched any of the green marbles, so there's 11 out of 38 chance. And what is the probability that we pull red, then blue, then green, in order? You're probably thinking pretty small, and you'd be right. You got to take all these and multiply them up. 1/5 times 4/13 times 11/38 gives you 44. Over 2470. Which is 22 over 1,235, which is a pretty small chance. Try this one on your own. See if you can do it. I'm going to write the yellow in blue just because it doesn't show up very well. I would pause the recording now because I'm going to do it real quick in a second. Actually, I'll do the yellow with orange just because it does show up enough. That's the first yellow. Second yellow will be only 8 yellows left out of 38. That's the second yellow. I'm not going to write it out, but multiply them all together. And you get 36 over 2470, which is 18. Very interesting, over the same exact fraction. Try the last one on your own. and then I'll do it real quick. Now I've taken one red and I've taken one yellow, so there's 7 plus 8, and there's still 12 blue. So that's 27 not green. We're down to 38 of these. That's it. Multiply them all up. I get 81 over 2470. And I see the fractions are always similar, so I know I did my math most likely correct. It's tricky stuff. Flipping over. We could have a mutually exclusive event. This means that we're calculating a probability of event one or the other. In this case, we add. We don't multiply. Deck of cards has, for those who don't know, 52 cards, 4 suits of 13, 4 cards of each number, even though we have a Jack, Queen, King, I'll just call it number. So what's the probability card? Is a heart or a diamond? Heart is 13 out of 52, also known as 1 out of 4. Diamond is 4 out of 52, also known as 1 out of 13. Take the two and add them together. Get 17 out of 52, which makes sense. That's how many cards there are in the deck on the bottom, and that's how many hearts or diamonds there are on the top. It's almost a 1 out of 3 chance. Now, what if the previous question asked for a heart or an ace? The problem is we have an overlap here. So we know that heart or diamond would have been 17 or 52. Made a mistake here, my mistake. Heart or diamond are separate suits. Read the problem wrong. 13, 1/4, just 1/4, plus 1/4 gives us 1/2. So it's basically half the deck. Now what about a heart or an ace? Actually, I just did that math, so I'm going to just do it again. 1/14 plus 1/13, but what about the ace of hearts? My impromptu art. Should have written it in red. We got to subtract that one out. There's 1 out of a 52 chance you end up with the ace of hearts. So that is mutually exclusive events that have an inclusive aspect. Add them together like you did before. Subtract out the one that overlaps. You will get 4 out of 13 when you're all said and done. 4 out of 13 chance that you're going to pull a heart or an ace. So that's what we just did up here. We go the probability of a heart plus the probability of an ace minus probability of the ace of hearts. And the best way to get good at this is just practice. So we'll get you lots of examples. Now I've done a nice job confusing the heck out of you. Thank you very much. So I'll give you a challenging problem. You might want to pause the tape, try it on your own. An electronics store gets a shipment of 5 TVs, and they always find the one that is defective. So they say, well, let's just test 3 of them, and hopefully we find it. What is the probability that they test a defective player? And is this an independent or dependent event? It causes all sorts of confusion for people. I felt like it was a dependent event, and then when I stopped and thought about it, I realized it's an independent event. Because when I test the first TV, I have a 1 out of 5 chance of getting the defective one. And whether I find it or not, I still had a 1 out of 5 chance on the next one. Because anytime I just grab any TV, I have a 1 in 5 chance. These events do not impact each other. If I find it in the first one and I know it, well then yeah, that's another thing. But when I'm just sitting down to calculate the probability, I don't know anything. I don't actually know what's going on yet. So I just have to add them up, which gives me a 3 out of 5 chance. And if you think about that, that's a 60% chance. That makes all the sense in the world. There's 5 TVs. I test 3 of them. I got a 3 out of 5 chance that I'm going to find the defective one. So this is where probability gets very confusing. We'll give you lots and lots of practice to try and get you on top of it, so don't panic. We'll get you going from there. Good luck.